let's say given this diagram right over here, we know that the length of segment AB is equal to the length of AC. So AB, which is this whole side right over here, the length of this entire side as a given is equal to the length of this entire side right over here. So that's the entire side right over there. And then we also know that angle ABF is equal to angle AC, or you could see their measures are equal, or this implies that they're congruent, or they have the same measures. And it's equal to angle ACE. So this angle right over here is congruent to that angle right over there, or you could say that they have the same measure. Now the first thing that I want to attempt to prove in this video is whether BF has the same length as CE. Does BF have the same length as CE? So let's try to do that. So we already know a few things. I could do a two-column proof. Actually, let me just do it, just so that in case you have to do two-column proofs in your class, you can kind of see how to do them more formally. So let's write our statements. Statement. And then over here, I am going to write my reason for the statement. So let me just rewrite this, just have a formal two-column proof. So we know AB is equal to AC. So this is statement 1, and this is given. We know statement 2, that angle ABF is equal to angle ACE. Once again, that was given. Now, the other interesting thing, we have an angle and we have a side on each of these triangles. And then what you can see is both of the triangles, and when I say both of the triangles, I'm talking about triangle ABF and triangle ACE. And they both share this vertex at A. At point A is a vertex for both of these. So we could say angle A, we say BA, let's call it BAF, angle BAF. We could say is equal to angle BAF, or we could say it's equal to angle CAE. Angle CAE, and that makes it a little bit clearer that we're dealing with two different triangles right here. But it really is the exact same angle. It's equal to itself right there. That's our third statement. And we could say it's obvious. Some people would call this the reflexive property, that it's obvious that an angle is equal to itself. And so we could say it's obvious, or we could call it maybe the reflexive property, that an angle is clearly reflexive, obviously equal to itself. Even if we label it different ways, this angle is going to be the same measure. And now we have something interesting going on. We have an angle, a side, and an angle. An angle, a side, and an angle. So what we end up having is that triangle. So by angle, side, angle, we have that triangle BAF. So our statement number 4, I'm running out of space right here. Statement number, I'll go down here. Statement number here is triangle BAF. Triangle BAF. And let me kind of highlight it in a little blue right here. BAF. So that's this entire triangle right over here. And half of the trick of some of these problems is just seeing the right triangle. So we started with this white angle. We went through the side that we knew, and we went to this orange angle right over here. We started at this angle, then we went to this orange angle across the side E that we know is congruent to that side over there, and then we went to the side, the angle, the vertex that's not labeled. So BAF, triangle BAF, we now know is going to be congruent to triangle. We start at the white angle, go to the orange angle, and then go to the unlabeled angle. It's going to be congruent to triangle CAF. So this is kind of a messily drawn version, but I think you get the idea. These two triangles are going to be congruent. CAE, I should say. It's congruent to triangle CAE. White angle, orange angle, and then the unlabeled angle in that triangle right over there. And this comes straight out of angle, side, angle. This comes straight out of ASA, and this is one angle, and this is the side in between, and these are the two angles. So it comes out of statements 1, 2, and 3. And so they are congruent. We know that corresponding sides are going to be congruent. So we know our statement 5. I should do this a little bit neater. Our statement 5, we now know that BF is equal to CE. BF is equal to CE. BF is equal to CE. And this comes straight out of statement 4. And we could say corresponding sides congruent. Corresponding sides are congruent. Now let's take it up another notch. Let's see if we can prove whether ED is equal to EF. So what we need, let's just keep going down this and see if we can prove whether ED is equal to EF. I put a question mark there because we haven't necessarily proven it yet. So I want to prove that this little short line segment ED is equal to, sorry, not EF, is equal to DF. ED is equal to DF. ED is equal to DF. So let's see if we can prove this right over here. So the interesting thing that we might, at first it might not be so obvious, how do we figure out some type of congruency over that? But we do already have some information here. We know that BAF is congruent to CAE. So we also know that this side right over here, let me do it in a color that I haven't used yet. Let me see, I've been using a lot of the colors and maybe my palette's getting a little too. So we know that from these two congruent triangles that side AE, which is part of CAE, we know that AE is going to be equal to AF, that these two sides are congruent. And the reason why is because they're corresponding sides of congruent triangles. AF is the side opposite the white angle on BAF, triangle BAF, and AE is the side opposite the white angle on triangle CAE, which we know are congruent. So we know that AE is equal to AF. And once again, this comes from statement 4, and we could even say corresponding sides congruent. Same reason as we gave right up here. Now, what's interesting here is, this isn't even a triangle that we're seeing up here, but this information that these two characters are congruent help us with this part over here, because we know that AB is equal to AC. That was given. And so we know that EB, let me write it over here and I'll make it a little bit messy right over here. Statement 7 we'll give us some space. We know that BE is going to be equal to CF. So let me write that down. We know that BE is equal to CF. And why do we know that? So let me put the reason right over here. Let me try to clean up my work a little bit. This column has been slowly drifting to the left. But how do we know that BE is equal to CF? Well, we know that BE, the length of BE, is equal to the length of BA minus AE is equal to the length of BA minus AE minus, or I should say AB. That's how I call it up here. So it's equal to AB minus AE, which is the same thing based on these last few things that we saw as saying AC minus AF, because AB is equal to AC, so that's equal to AC, and AE we already showed is the same thing as AF, AC minus AF, and AC minus AF is the same thing as CF right over here, is equal to CF right over there. And we know that because, and we know this from statement 1, we know it from statement 1, we know it from statement 5, and we know it from statement 6. Actually, we didn't need statement 5 there. Let me see. We just need 1 and 6. So let's say we need, this is from 1 and 6 is what we had to do there. So we just know that, look, this side is equal to that side, this little part is equal to that part. So if you subtract the big part minus the little part, this right over here is going to be equal to this right over here. That's all we're showing. So this yellow side is equal to this yellow side right over here. Now, the other thing that we know, and this is straight out of vertical angles, is that this angle, EDB, is going to be congruent to angle FDC. So let me write that down again. So 8, we know that angle EDB is going to be equal to angle FDC. Is going to be equal to angle FDC. And that comes straight out of vertical angles. Vertical angles are vertical angles are congruent, or their measures are equal. And now all of a sudden we have something interesting again. We have the orange angle, white angle, side. Orange angle, white angle, side. So we know that these two smaller triangles are congruent. So now we know, and I don't want to lose my diagram, we know that triangle BED, so statement number 9, we know that triangle BED is congruent. So BED is this one. We know that BED is congruent to triangle, and we want to use the same sides. White angle, yellow side, then orange angle. White angle, white angle. Let me be careful here. White angle. So B is white angle, E is the unlabeled angle, and then D is the labeled the orange labeled angle. So we want to start C, unlabeled angle, orange angle. So CFD. So triangle CFD, and this comes straight from, once again, orange angle, white angle, side. So angle, angle, side. Orange angle, white angle, side. So this comes straight out of angle, angle, side congruency. And since we've now shown that this triangle is equal to that triangle, we know that their corresponding sides are equal. And then this is our home stretch. We now know, since these two triangles are congruent, we now know that ED is equal to DF because they're corresponding sides. And I could write that right over here. ED is equal to DF. And once again, the reason here is the same thing up here, corresponding. So we know our statement 9, which means they're congruent, and corresponding sides congruent. And we are done. So that was a pretty involved problem. But you see, once again, you go step by step. Just try to figure out whatever you can about each triangle, and you eventually get it. And really, the hard part isn't so much the realizing which postulate to use or how to apply them necessarily, but seeing the triangles, seeing that there's some information there, seeing that you can figure out BE by subtracting it by subtracting AE from AB, seeing that there are two triangles kind of overlapping in this star without arms, or whatever you might want to call it.